Hello, this is Professor Dan Kernler of Elgin Community College, back with another video in my statistics series. In this one, we're going to dive into the specifics of hypothesis testing about a proportion. Okay, let's get to it. We're going to start off today actually talking about Elgin Community College and some of the math classes we have and how you can get into those classes. And then we'll do a little hypothesis testing. So we have four kind of entry-level, college-level math classes. We have statistics, gen ed math, we have math 110, which is math for elementary educators, and then we have college algebra. There's a variety of ways you can get into these. Math 095 is basically preparation for gen ed math. So that just gets you into 102 and 104. Math 98 is intermediate algebra. That can get you into all of these. There's also Math 99, which is a combined beginning and intermediate. Then you can get an SAT or ACT score that's high enough. Same thing on the ALEX placement exam. And then relatively recently, we added this high school GPA, which was a statewide initiative. There was legislation that was passed. We had been investigating this as well. We know students that do well in high school are likely to do well in college as well. So I wonder if that last group who did well in high school actually is more likely to succeed in college than the other groups that were in there. Well, what we could do is we could look at the overall success rate in these classes. It's about 71%. And then we have a sample of students who've come into ECC and they got into those classes without any placement exam, without any SAT or ACT. They just had their high school GPA score. Plus you had to have fourth year math class as well. And of those, 50 out of 63 were successful in one of those four classes that they took. This was in a single semester, I believe. I can't remember exactly when this was implemented. It might have been fall 2020. So we have a sample proportion then is 79%. Clearly higher, but only 63. Maybe it's not statistically higher. So let's test it and we'll go through this hypothesis testing process. Remember, this only works, we can only do this hypothesis test if we have this criteria met that n times p times 1 minus p is at least 10, and we have less than 5% of the population. If those conditions are met, then we'll fit this normal distribution. So we have 63 here. The p proportion will be the 0.71. Plug those in. Yes, that is at least 10. And we do have less than 5% of all possible students taking these classes. Okay, so if those conditions are met, then the mean of the sample proportions will be the same as the population proportion, and the standard deviation will be square root of p times 1 minus p all over n. Fill in those values. We get 0.71 is our proportion, and we get a standard deviation of about 0.0572. And now that we have the mean 0.71 and the standard deviation, we can look at our value that we have here. We have 71% that we're comparing with, and then 79% is our sample. We can figure out where those go on the curve. So 50 over 63 is over here. The p-value would be the probability of getting that value or more extreme. In this case, that's about 0.072. We could also compute a z-score here, 50 over 63 minus the p over the standard deviation. We get about 1.46. That's a z-score. We can treat that as a z and do the same thing. This would be if we wanted to do the critical value method. To do the critical value method, we need the value that has 0.05 to the right, or whatever our alpha is. In this case, z.05 is 1.645. So now let's go through those 6 steps. We have to first define the null and alternative hypotheses. Our null hypothesis is that the proportion is the same as it was for the other groups. For the alternative, remember there are 3 possibilities here. So here's the distribution under the null hypothesis. Now we could suspect, hey, do we think it's greater than that? Or do we think it's less than that? Are we not sure? Could it be less than or greater than? So we put a not equal to. So there's 3 possibilities for the alternative. In our case, I was wondering if these students did better. So I was wondering if the success rate was higher, so greater than for this particular example. Now we have the alpha, determine alpha, the level of significance. A good default choice here is 0.05. You don't have to choose that. Compute the test statistic. So that's this test statistic in this case. You take the sample minus its mean, which would be the population proportion, and divide by the standard deviation. And that's the 1.46. For the p-value, You're just going to find the probability of being to the right of that 50 over 63, and that's 0.072. For the critical value, we need to convert these to z's. So we have our 1.46. We need to find the z with 0.05 to the right, and that was 1.645. All right, we have those two in there now. Now we need to make our decision. Do we reject the null hypothesis or not? In both cases, we look at the p-value. It's not below our threshold. And the 1.46 is not in the critical region. It's not above 1.645. So that would mean we do not reject the p equals 0.71. Now, this is really important. I'm using the language we're not going to reject the null hypothesis. The null hypothesis that the proportion for this group is also 0.71 might not be correct. It might be 0.72, 0.74. It might even be 0.84. We don't know. All we can say is that we're not going to reject that it's 0.71. Okay, that's all we can say. And when we have our conclusion, we say, okay, there's not enough evidence at the 0.05 level to support the claim that the proportion is more than 0.71. So we had 79% was our sample proportion, but because we only had a small sample size of 63, that wasn't statistically significant. We do not have enough evidence to say that it's higher than 71%. All right, let's talk about how to do this in StatCrunch. This is going to be stat proportion stats, one sample, and here we're going to do with summary. It feels like we have data, but we actually just have the summary. We had that 50 out of 63. So now we go and we enter in our counts, 50 out of 63. For the proportion, we're going to compare to 71.71, and then we'll hit compute, and we'll see our p-value. In fact, we'll see our z-test statistic there as well. Here's another example. I found this information from the US Census that of those who are eligible to vote, 71% were registered to vote for the last presidential election. So we might wonder, we have our Children of Immigrants database. And I wonder if the proportion of those who are eligible to vote who registered is different. Now, it's important to note, we have their citizenship status. They're not all eligible to vote. We have 84% of them are eligible to vote. So the question we're going to ask, and we're going to ask this before looking at the data, is the proportion of eligible voters who are registered different for children of immigrants than for the general population? So pay attention to that phrasing. If we look at, actually I made a graph here for the proportion of those who are eligible who are registered, and it's actually 77%. Now keep in mind, we've talked about this before, we should read the details of this database and how these data were collected. It's possible that this sample doesn't represent all children of immigrants. We had a much higher education rate, but the only thing we can do is take it at face value. So we have a 77% voter registration rate for those who are eligible to vote in this Children of Immigrants database. Let's do this in StatCrunch. This is a little tricky. So we're going to go to Stat, Proportion Stats, one sample with data. The variable we want to look at here is registered. So we'll scroll all the way down, but this is a little tricky. We want to just pick those who are eligible. So we have to exclude those who are not citizens. And we can do that where there's this where box. So we'll go in, we're going to build a formula, and we're going to build a formula where if you scroll down, that's their current citizenship. So we want citizen now is not equal to, so it's a little weird, it's an exclamation point and an equal to, is not equal to, and then not a citizen. Okay, so a little tricky there, but then we can do our null hypothesis, p equals 0.7, alternative would be not equal to, and then we'll go down and hit compute, and we have our results. So we have our test statistic pretty high here, 7.51. For the p-value, we'll go take a look at the StatCrunch output again, and we can see with a z of 7.51, that's basically off the scale. Remember, 3 standard deviations each way is 99.7%. So we're just going to have p-value less than 0.001. So here we did have an extreme observation. So we would reject the null hypothesis. So our conclusion then is, in this case, there is enough evidence at the 0.05 level of significance to support the claim that the proportion of eligible voters who are registered is different for children of immigrants. So in this case, there is enough evidence to support our alternative claim. One last little note I want to make here. It's important to understand the difference between statistical significance and practical significance. You have to look at your sample statistic and the one you're comparing with, and just because they're statistically significant doesn't mean that it has any practical meaning. In this case, we had a sample proportion of eligible voters who were registered was 77%, and the comparison was 71%. In my opinion, that difference of 6% is pretty significant. That has some meaning. It was statistically significant, but it seems to be practical. Whereas if you had a difference between 71% and 72%, yeah, it might be statistically significant, but does it actually have any meaning? So be sure you're kind of thinking deeply about your results, and just because you get a statistically significant result, does it actually mean anything? Is there actually a meaningful difference between those? All right, that is it for this video on hypothesis testing about proportions. I hope this was helpful. If you're interested in seeing more of these, you can subscribe, hit the bell to get notified. We've got a whole series of these coming out, a bunch more about different hypothesis tests. As always, thank you to the Elgin Community College Board of Trustees who approved my sabbatical for the spring 2021 semester, and that's how I was able to record all these videos for you. And thank you so much for watching. I will see you in the next one.